Okay, I told you guys I would do a video for the graphing of the secant and cosecant functions. There's kind of two ways I want to show you how to do this. Um, so if you are just looking to know exactly what the end product looks like, I will show it to you right now. It looks like this. Okay, the pink specifically is the right function. I'm going to go ahead and cut that for now and explain how to do it, but hopefully if that's all you were wanting, then you paused the video and got what you needed. So the first way I'm going to show you how to do this is to realize that cosecant is equal to 1 over sine. And we can use the sine graph to do this graph. So you'll notice that on cosecant, this is the sine graph that it's kind of like not showing you right here, right? So what you can do is you can actually adjust the sine graph and use that to adjust the cosecant graph. So I will show you guys just kind of what I'm talking about there. So the first thing I'm actually going to do though is the asymptotes because those are important. So the asymptotes on a cosecant function are 0 plus pi k. Okay, so we're going to have one at 0. Make that a little darker. We'll have one at pi, 1 pi. We'll have one at 2 pi. We'll have one at 3 pi, we'll have one at negative pi, we'll have one at negative 2 pi, etc., right? So we've got all of these asymptotes that are just part of the cosecant graph. So that's the first thing I'm going to do and deal with. Okay. And then I'm just going to think about what a normal sine graph would look like. So it would be like this, right? And therefore, a normal cosecant graph would just be up here and down here, and it would touch those two things. Except for I just did that backwards, I think. I don't know. Should be there and there. I hope I did that the right way the first time. Okay. But we've done some things here, right? So we have shifted up 1, and we have also stretched by 2. So remember, we should do stretches before we do shifts. So 0 stretched by 2 is still 0, but 1 stretched by 2 comes up to 2. So this one stays at 0. This negative 1 comes down to a negative 2 because negative 1 times 2 is negative 2. And 0 times 2 is still just 0. So that kind of shifts it to this curve here. Okay, so there's that one. And then it does also move up 1. So every point moves up 1, including kind of our like midline here, right? Our baseline here also has moved up now to here. Okay, so then it looks like this. Okay, and I'm going to ditch that midline just because I think it kind of muddies up the graph a little bit, but keep in mind that that baseline does move up. Okay, so we've got this nice lovely sine graph, and 1 over cosecant is 1 over sine, and so what always happens is they're always going to share this point. This one's going to be like this. They're always going to share this point, so this one's going to be like this. And I want us to do 2 full periods. So remember that that's only 1 period of this one, right? So really all we've done is like moved it up and stretched it out a little bit, okay? So we also have to do it over here, but remember, don't redo work you've already done, right? So this one should be over 2 pi from where it is, right? So that's 1, 2 pi. So we're going to put that right there. And this one should also be shifted over 2 pi, so that's 1, 2. This one should be here. Okay. And then we just have to graph our little curves here. If you don't like this one over here because it gets on the graph, that's fine. You could also put it here. Just realize that it's going to go off the graph a little bit this way. Okay. And there you go. That's how you can do a cosecant graph. One way, I guess I should say one way you can do a cosecant graph. Okay. Another way that you could think about these, let me erase my scratch work here. Another way that you could think about these is just like the actual function. If you have what that function normally looks like memorized, then you can just do it transformations just like you always have. One note on this one, you do need to rewrite because you got to make sure your amplitude, or not your amplitude, I'm sorry, your period change and your shift are kind of dealt with separately. So you need to pull that out, okay? So secant has asymptotes right here and here, etc., right, at pi halves plus pi k. Okay, so pi halves plus pi k, all right, but again, we have adjusted this by 2, so we would actually take all of this and divide by 2, so this would be pi fourths plus pi halves k, which I know is kind of a strange way to wrap your brain around this, but that means that it's going to be at pi fourths, which would be right here. This is our pi fourths mark, and then it would be plus another pi halves, so pi fourths, and then every time we add a pi half, that would change it, right? So this would be 3 pi fourths is our next one, okay? So then we're going to have 3 pi fourths be our next asymptote, and then we're going to have one here too, okay? And we can go the other direction also. But before you do too many of these, I do want to make sure you guys realize something important here. We're going to have to shift these. So if you're writing this, you may want to hold off. I have this cool feature where I can say, hey, take all of these and move them over, right? So we want to go right by pi halves. So I can pick this up and be like, hey, just kidding, I'm going to move this over too. And that's easy for me, but you may want to hold off on writing them until you have them in the right spot, right? And then I'm going to take this one that's now off the graph and put it back over here. Okay, again, perks of technology, but I know you guys can't do that on yours. So keep that in mind. So now, also, when we shifted everything, so I'm actually going to unshift for just a second. So a normal secant graph would be looking like this here, and it would hit the 1, and like this here, hit the -1, hit the 1 here, this one would come up and hit -1, this one would be down here, this one would be up here, right? That is what a normal secant graph looks like. Well, we've done a couple things here. Well, I guess that's not true. This would be a normal secant graph with the smaller period. I have already done the period. But we do need to shift right. So I'm going to pick up everything I have, and I'm just going to shift it right to a little bit here. And just be really careful that you get it in the right spot, right? So pi halves should be at 1. And again, these kind of go off the graph, so I'm going to pick them up and move them. And then they have to switch, actually, because they're in the wrong order now. So we'll just erase that part. So this one would be down here. That one would be up there. Okay, so now we've done both the period change and the shift. And you can think about these graphs that way if you prefer. I personally would have done, well, secant is 1 over cosine. So I would have said 1 over the cosine graph would be here, here. Let's see, so to 2 pi. Would have been something like this, right? Okay, so it would look something like that. And then we changed the amplitude of it. Or sorry, we changed the period of it and shrunk it down. So actually by pi it should repeat. So now it's up here, right? And then we did the shift to the right by pi halves. And moving that right by pi halves would put this over here on pi. But it actually would also go to the left a little bit here. So it ends up being trying really hard to get this right for you guys, but it's really hard to do it. Okay. So the shifted version of the cosine ends up there. And remember that it's opposite, right? So it would actually look a little bit different than that, I suppose. It's hard to do both methods at once, but just keep in mind that that is an option for you, that you could do it the other way. Okay. So the next one, how are we going to write the equation? So the first thing I'm going to look at is the secant or cosecant. Okay, so this one is in the middle of an arc at 0. So that may help us know what to do with it. So the middle of an arc at 0 is, of course, secant over here. Okay, so we're pretty sure this one's secant. And then we got to figure out some things. So some things you need to note. We are down here at 2 or up at -2 or up here at -2, which tells me that we have stretched this a little bit. So we're going to have a 2 there. And then as far as the period goes, the period should be 2 pi unless something's changed. So remember, a period would be from asymptote to second asymptote, which is what asymptotes are maybe not the best way to count these. So from like a crest to a crest is probably the better way to count these because you're going to guarantee they're always on the graph. So from -pi to pi is 2 pi in distance. So that means our period hasn't actually changed. So this hasn't changed. That's still just going to be an x. Okay. And then if this is secant, it should be right there at 0. So it hasn't shifted left or right at all. Okay. And then you can also check and see if it's moved up and down, which it hasn't. It was stretched, but it didn't shift after it was stretched. So we are actually done. That's actually the only part that changes on this one, is that it should be 2 secants of x. Okay, here's another one. I have another option for you of how you could go about this. You could kind of use these points to create the curve that you want. Okay. And you can kind of look and see, hey, is this looking more like a sine or a cosine function? And you can kind of decide. And I think if you're crossing at 0, 0, it's probably easier to use sine. So this one would be a sine, which means that this, the actual one you're working with, is therefore a cosecant because it's 1 over sine. Okay, so we're going to say it's a secant, or a cosecant, I apologize. And then we kind of got to decide what else we have to do to this thing, right? So then we can also check where is our midline? Where's our baseline here? So it should be halfway between here and here. So that's 1, 2, 3, 4, 5, 6, 7, 8. So our baseline should be 4. So 1, 2, 3, 4. So our baseline has been shifted a little bit. Okay. And so our baseline being shifted actually goes with our B value, right? So our B value is going to be +1. Okay. So we know that right now. And then we can kind of go from there and we can say, okay, so from our baseline to this point is 4. So that means that it has also been stretched by 4. And then we can take a look and see, has our period changed? And again, it's easiest to count from like a crest to a crest. So from -pi² to 3 pi², well, that's still 2 pi. Okay, so no change on our period. And then we can check and see if it has been shifted at all. And this one has not. Okay, so there we go. And then we can just go ahead and say that is the function for this one. Okay. So those are kind of the two options for you on how you can approach these problems. You can either think of them like the reciprocals of sine and cosine and deal with them that way, or you can think of them as separate graphs and adjust them that way. That's really up to you and the way that your brain works. Let me know what questions you have.